Good morning or good afternoon, ladies and gentlemen. Welcome to our webinar today on the CIPURSE open standard for HCE-based ticketing solutions. It will be introduced by myself, Laurent Kremer, and presented by Victor Brojac from Medius. As you know, I am the Executive Director of OSPT Alliance, and I am particularly happy to get the opportunity to present the webinar, which is the result of an intense work realized by the members. Before we start, I would like to remind you that attendees will remain muted throughout. To submit a question, please use the question box on the webinar dashboard, optimized by clicking on the orange arrow tab, top right of your screen, and just hit send. All questions will be answered at the end of the presentation if time permits, or within 48 hours. Now, I would like to introduce our presenter, Victor. Victor Brojac joined Medius more than 10 years ago, a newly formed company developing complex enterprise software solutions. Since then, he has become operations director and a key decision maker in Medius. He is also a chairman of the HCE working group within the OSPT Alliance. Webinar attendees today will learn, first, what host card emulation, or HCE, is, and reasons why transport operators should consider HCE. Second, why HCE and CIPURSE work so well together. Third, the best way to implement HCE with CIPURSE. And last, the applicability of the work beyond transport. But first of all, I will say a few words about OSPT Alliance and CIPURSE specification to prepare you for the rest of the webinar. OSPT Alliance is vendor neutral, an industry alliance funded by leading global technology vendors to promote an open, secure standard for public transportation fare systems and beyond. Its mission is to make fare payments for public transportation fast, secure, and convenient for the public, while reducing cost and complexity for operators. It develops, maintains, and certifies product compliance with CIPURSE, an advanced open standard for fare collection systems, and multi-application programs using contactless media. CIPURSE is especially optimized for contactless card and near-field communication-based fare collection system. One very important thing, it is vendor independent. All card suppliers can attain CIPURSE certification for their product. And technology providers are free to add functionality outside the common core, enabled by multi-application support. It ensures interoperability of all forms of contactless payment media, and it is highly secure. For more information about CIPURSE, please visit our website, www.osptalliance.org. So, why is OSPT Alliance interested in HCE? HCE has been a hot topic since about 2014, thanks to its enablement by Android and subsequent move by individual banks and the Payment Association. It seems to offer the prospect of simpler implementation of mobile applications. So, we decided to examine its benefit and complexities in public transport in detail. As a result, we formed a dedicated HCE working group The working group carries out ongoing work on standardization in this area. Its objective is to help transport stakeholders and other value chains, such as mobile banking and mobile commerce, for instance, to connect to the transport infrastructure using mobile NFC as a convenient addition to ticket vending machine. For example, for top-up of CIPURSE smart card and to single journey tickets. For instance, by paying for transport with a mobile NFC phone on buses. Besides, OSPTs provides audience with information about using mobile NFC technology to supplement traditional ticketing types and beyond. But OSPT engage also transport stakeholders and other connected parties to understand HCE requirements. Finally, OSPT evolves CIPURSE Mobile to support current and future HCE technology. To tell you more about our work, I will now hand over to our speaker, Victor. Victor, please.
Thank you, Laurent, for this introduction. It's a big pleasure to be a part of this exciting time for public transport that is so full of new technology, and to share and discuss this with the audience today. First, I would like to share a few general words about HCE. HCE is a technology that enables software emulation of a traditional tamper-resistant hardware device. Actually, HCE is a Google library running on all Android devices 4.4 and above. It has been endorsed by the payments associations because it simplifies business models. It is primarily seen as for use in retail environment, but it has great applicability to transport, as we are about to see, and as you can see from the diagram on the right-hand side of this slide, which shows a typical transit ticketing architecture. It can even be used in other application areas beyond transport, especially in association with CIPURSE, but I'll touch on this briefly at the end. A further point to note at this stage is that HCE enables the phone to communicate with cards too, allowing you to use your phone not just as a ticket, but also as a ticket vending machine. And finally, we should also note that cloud-based payment and CIPURSE 2 can of course work offline as well. Now I'll talk about HCE's benefits and constraints in the next slide. There are a number of potential constraints present in the transit environment to consider when using HCE solutions. Currently, there is a fragmented compatible user base and infrastructure, given that not all phone handsets can support HCE. HCE is not compatible at all with some proprietary contactless ticketing approaches. It may also struggle with throughput requirements, something that is particularly important to transit operators. Wireless coverage is not always reliable or even present, especially underground. And finally, there is a perception that it's not as secure as hardware-based solutions. But HCE also offers considerable value to operators. Let's look at how. It's a cost-effective and autonomous alternative to vending machines, information kiosks, and single tickets. Lower initial investment is needed, and it leverages existing infrastructure. The presence of a physical secure element is not needed, and that means that the system can be independent from mobile network operators and original equipment or device manufacturers. And very importantly, it enables interoperability between different closed-loop systems and offers a true multi-application environment. Now I'll talk how implementing HCE with CIPURSE, the open standard for transit ticketing, optimizes its benefits for the transit environment and what your options are for doing this. So why should you do this? The good news is that it's possible to implement HCE in a way that overcomes the constraints we just discussed, using CIPURSE. CIPURSE is open yet secure. It's a software approach that protects investment, yet it is flexible enough to be used with a secure element. It is fully compliant with open standards. And most importantly, it's the easy way to do it. In fact, much easier than attempting to use HCE with proprietary approaches, which is often not possible. So what are the different options? There are multiple ways of achieving this. Each approach has advantages and disadvantages. HCE without secure element, pure HCE, has no secure element. It's vulnerable to malware, not secure even with obfuscation. Regular key change is vital to make it work. We feel that the other options offer more promise in this environment. I'm going to go into other approaches in more detail in following slides. So very briefly, they are HCE with physical present secure element, so-called hybrid HCE. This offers a higher level of security because the keys and confidential data are stored in the secure element. HCE with remote secure element, online HCE. This offers the same capabilities to securely store the data, but with significantly reduced business model complexity, because no physically present secure element is needed. The mobile device does, however, need to be connected to the internet. Then we have account-based HCE, which is perfect for situations where the option of backend processing is possible. Sometimes this even means allowing customers to use the system even if their balance would otherwise not allow them to enter it. And finally, HCE with offline support, offline HCE. This involves a software-based secure element on the mobile device, and it is less secure but faster than online HCE. Now we will look in more detail at the options that most benefit from leveraging CIPURSE. With a hybrid HCE approach, the tamper-resistant hardware in CIPURSE is located on the mobile device. This can be achieved by using a SIM-based secure element, microSD, or a secure element embedded in the device. It's a highly secure implementation. But for it to work, there needs to be a way to access the secure element. This means we are depending on the mobile network operator or original equipment manufacturers who are usually the owners of the physically present secure element. The business model complexity grows accordingly. The secure element or access to the secure element may in some cases need to be specifically designed to support different devices. The next option is online HCE. With online HCE, the secure element and CIPURSE reside in the cloud, meaning no infrastructure upgrades are needed, making it easy to implement to the existing environment. It is independent and flexible with a reduced risk of credential theft. Most of all, makes it easy to achieve a multi-application environment. For example, to add another card structure in the cloud, tailored to service providers' needs, it's very easy because it can be managed over the web application by using defined APIs. But of course, there are issues. Firstly, network availability. What if there is no signal? Throughput speed is also lower than with physical secure element because of the latency when communicating with the terminal and cloud. This can be a major issue when throughput on the turnstile is the key point for public transport operator. It is also less secure than physically present secure element solutions. So how about account-based HCE? In this option, the device is used to store a credential which is sent to the terminal for backend processing. Multiple devices can be supported, for example, phones and cards, and so can multiple ticket types. CIPURSE, with its uniform way of handling multiple fare media types, supports account-based functionality readily, as the feature set required for account-based is a subset of the feature set for stored value. CIPURSE can be used to recognize the user ID as valid in real time. Additional CIPURSE functionality, such as the ability to recognize key variables, can be used to manage risk associated with an account, such as whether the account has been recently recharged, has repeatedly been flagged for bad debt, or is invalid. And the final option that I'm going to present is offline HCE. This option is actually a good fit for most existing transit architectures, and it also complements existing smart card programs. Laurent, can you please mute your microphone so there is no background noise? Thanks. It may appear to be less secure than using a secure element, but today, appropriate mitigation techniques to reduce risk already exist. Moreover, often the existing systems have secondary levels of protection in place due to the fact that many legacy secure elements have been hacked. Offline HCE allows for a multi-device approach, including the use of CIPURSE smart cards. It creates opportunities for collaboration, such as connecting transport account with payment, mobile network operator services, and loyalty programs. So providing offline support while limiting impacts on the validation and inspection infrastructures already in place comes down to provision of a tokenized credential. Right now, CIPURSE does not support tokens, but that's about to change as work is underway to enable this. We will talk about tokens more shortly. So those are the different options, but I promised a few further words about tokenization. In fact, tokens enable a perfect combination of online and offline HCE. While we are connected to the internet, we generate the token and store it to the device. The token can now be used even when there is no network coverage and the device is disconnected from the network. Thus, we dramatically reduce the transaction time because we eliminate latency and all the processing is done between the terminal and the device. Of course, there are questions of how to provision tokenized transport credentials and how to protect tokens within the device. We can, however, manage residual risk using a hosted system. Tokens are natural fit in transport, and the transport network with tokenization capabilities opens up collaboration possibilities in bridging with other ecosystems in payments, mobile, and retail. So it's worth spending a few more minutes on ways of protecting tokens. Although offline HCE with tokenization limits impact on existing infrastructures and benefits from existing protections such as shadow account management, transit authorities should invest in additional card and product tracking solutions and remotely upgradable mobile software protections and acceptance infrastructures. Possible implementation options to protect tokens offline include obfuscation and white box cryptography, verification using mobile phone factors, device and application specific security, using a trusted execution environment on the device, or using a CIPURSE secure element. In reality, this is a highly complex subject that we can't go into great depth about here. and I'm just scratching the surface, but there is a lot more detail in our white paper on HCE, so I highly recommend reading that if you haven't already. You can download it from the OSPT Alliance website. Now let's look briefly at the use case. In this use case scenario, we have an existing transport network. An existing transport network requires passengers to queue at a ticket vending machine or a manned point-of-sale terminal to top up transport credential. This means a loss of passengers' time and increased operating expense. This is especially acute in highly populated areas, where there are never enough ticket vending machines at the rush hours, as well as in sparsely populated areas where there is not enough users to amortize the equipment. Also, ticket vending machines are quite expensive to procure and maintain, and to top up load by a third party triggers significant sales commissions and costs to the public transport authority. So the solution is, a mobile application is downloaded by the passenger on their NFC phone and used instead of the ticket vending machine or point-of-sale terminal to top up or load a transport credential. So why use CIPURSE and HCE for this? CIPURSE being software-based only. A mobile NFC phone ticket vending machine function can be supported by existing transport issuer ticket vending machine security management functions through all HCE approaches, even online HCE. CIPURSE, L, S, and T profiles used in native or Java implementations all use the same protocols for authentication, secure messaging, etc., and thus are scalable across transport credentials. And the mobile vending application only needs to comply with the Public Transport Authority API's specification. And this is quite a small incremental step for the Public Transit Authority and the standard Java environment for the mobile app developers. That's a brief explanation of one use case. OSPT working groups are dedicated to supporting such use cases, alongside developments to elevate the Public Transit Agency specification to industry standards and certification of implementations, and so on. Now to summarize. So in summary, there are multiple benefits. Using CIPURSE is the wisest way to implement HCE, avoiding future complications arising from being trapped by a proprietary technology and overcoming key weaknesses in other approaches. CIPURSE also brings additional security benefits, and it is flexible and fits into an existing operator ecosystem. But that's not the final word. We are already working with OSPT Alliance to further ease implementation. Next steps for working group are to evaluate the impact HCE has on the CIPURSE specification and decide if updates are needed. Possible results of this work may be faster and simpler authentication methods, asymmetric algorithms for one-way authentication such as elliptic curve crypto protocol, and more importantly, the creation of a reference application example using CIPURSE token. If you have any interest in HCE and transport ticketing, we urge you to join this activity. And please contact me directly or us via our OSPT Alliance website. Now, as we will briefly see, HCE and CIPURSE can also work together in other application areas. The work we have done on HCE has relevance beyond transit and retail payments. Other applications enabled by CIPURSE include event ticketing, loyalty, access control, mobile value-added services for account management, and of course, multi-applications. In all of this, HCE may be very valuable. There is a reason for this. In many sectors, there is a demand to shift from a technology-centric to user-centric approach. The path to success is the ability of a service provider to propose a list of services that the user can choose himself on the spot when and if he requires it. Let's think about a traveler arriving for the first time at an international airport. He wants to rent a car, to get access to a parking lot, to buy a train ticket to go to the city, and that's just a few things. An open standard such as CIPURSE, in combination with HCE, can be a true enabler and bridge all these services and diverse technologies onto an existing infrastructure. Thank you for your attention. Now I will hand back to Laurent to finish up the webinar.
Thank you, Victor, for such a valuable explanation of HCE in transport ticketing. I will now conclude the webinar with a few further words before opening for questions. This next point is truly important. OSPT Alliance continues to welcome new members. So, if you would like to get involved with our work on HCE and, of course, other important topics, including system standardization and compliance, please join the OSPT Alliance and participate to our working group. You have a list of the main working group on the top of the slide. And to finish, we are happy to take questions. Please use the box on the webinar console or contact us directly. Anyhow, if your question has not been answered during this session, we will make our best to answer it in the coming 48 hours. We will start with a few questions that came in during the presentation. So the first question we have received is asking for, on the subject of tokenization, how should a public transport authority go about choosing a TSP? Victor, would you mind to answer this question?
Yes, of course, Laurent. And thanks for muting yourself earlier. First of all, maybe for those not familiar with the terminology, a TCP abbreviation stands for Token Service Provider. So token TSP is an entity within the ecosystem that deals with token issuance, replacing payment or transport credentials. The concept is more, I would say, familiar from the payments industry, where banks have a number of options to choose from. But primarily, TCPs are the payments associations. Secondly, we have third-party transaction processors. And lastly, some in-house implementations. And the payment associations impose constraints on banks. For example, payment scheme participation, business rules, processing costs, terminal specifications. And I think all these constraints have usually little relation in most cases for public transit agencies' business rules. So personally, I would go for the other two options, the second or third one. Indeed, a transport network with tokenized capabilities of its own can open collaboration possibilities to bridge its network with other digital service networks in other fields.
Thank you, Victor. A second question was related to, can you say a bit more about throughput?
Sure.
Are you, yeah?
Yeah. In most mass transit implementations around the world, throughput during a high load usage. This means interactions at the gate or upon boarding a public vehicle is a very important subject. It's actually also a matter of safety, but it's also often it also often has an impact on revenue. And in such context, HCE needs or would need to perform well under 500 milliseconds per transaction. And today, this is not always the case because HCE is not always on, or it's not always exclusive, is sometimes running on the processor of the phone with some other application. And it also depends on the speed of one's network connection. So in clear blue sky scenarios for 3G or 4G network, we face latencies of, I don't know, about 100 milliseconds plus minus 40%. And of course, a minimum of 2 round trips to go to the server and back. Clearly, things may change somewhat in 5G scenario, but that's still some years off. But however, this forthcoming change does mean such investment should be worthwhile, since 5G networks will most probably reduce latency dramatically and thus enable also online HCE across all public transit use cases. But in the meantime, the scenario I discussed on the tokenization slide, where the tokens are downloaded in advance, takes care of the throughput issue. So this would
Thank
be...
you, Victor. Anything you want to add?
No, I think that's enough.
Okay, we have still some time for question. I understand that we started about 33 minutes ago, and we are planning to not to exceed 40 minutes. So we have at least time for 1 or 2 more questions. During the use case slides, there was mention of CIPURSE L, T, and something else that I didn't catch. Could you talk a bit more about this? Okay, maybe I can start this one, and if you have something to add, Victor, feel comfortable to add.
Okay, thanks.
CIPURSE has defined a number of specifications which have been developed by the OSPT Alliance. So as well as the core CIPURSE operational interface and cryptographic protocol, we have defined 3 profiles to address different needs. The first one is CIPURSE T, the more complex, the more high-end, multi-application with transaction support and post-issuance personalization. Then we have the intermediate product, which is we call CIPURSE S for CIPURSE standard, which is predefined for multi-application profile. And lastly, we have the CIPURSE L to signify limited use ticket. What makes CIPURSE special is that each profile uses the same protocol. So in HCE, a mobile application will use the same few lines of code to work with any of the CIPURSE compliant implementation. Whether you have a single ride ticket or a reloadable purse or a voucher, for example, this will apply. And this is true for any environment or form factor. We have also specified terminal components like the CIPURSE SAM specification, which are also available onto the website. And we have started to address the background system with a key management guide. So please don't hesitate to visit our website. You will also have access to a more technical focused webinar that is available. and that has been presented by the technical working group, which goes in details with those profile mentioned above and the capabilities of each profile. In case you have more questions, don't hesitate to contact with me. My contact details are available onto the website, and I will, of course, transfer your question to the working group in charge of the related to your question. Victor, do you have something to add on this?
No, I think it was perfect.
Thank you. Yes, there is another question which is asking for a bit more information related to interoperability. Victor, can you address this?
Mm-hmm. Yes. Interoperability is of the essence for many international and regional travelers. For example, I want to travel from country A to B with different means of transport and with different public transport organizations, and only want to buy a single ticket or use a single application to buy through a multi-application environment. And I think HCE can be leveraged as an elegant way to provide such interoperability between separate closed-loop transport networks. In particular, when coupled maybe with account-based transport credential. So interoperability between transport and non-transport is already found in many public transport networks, I think. This is conventionally enabled using a common smart card PURSE application. And using HCE with CIPURSE will work perfectly with a PURSE. Nonetheless, interoperability between public transport and other ecosystems, especially payment, mobile, and retail, it's not always part of a public transport's core mission. And HCE can be leveraged in situations by maybe linking side by side a general purpose account, for example, supported by a mobile terminal, to a public transport tickets or smart cards, which are compatible with existing legacy infrastructure. And I think CIPURSE is particularly well suited to enable this, as the specification goes well beyond just transport ticketing. Would you like to add anything, Laurent? Or?
Well, we have received some question related to iPhone. So we have still 1 minute. So are you in condition very quickly to tell you? You have been talking about Android. So what's going on with iPhone?
This clearly is a very popular question. I remember we received it yesterday as well, and my answer remains the same. So at present, of course, iPhones have contactless capabilities, but it is true that iPhones currently do not support HCE implementations. But moreover, the contactless chip cannot be used by a third-party developer, and it's closed. But in my opinion, I think if Apple wants to utilize the contactless technology and offer other contactless services beyond Apple Pay, I think they will certainly need the development support of the community. So we cannot, or at least I cannot tell what Apple will decide or do in the future regarding the NFC chip, but I hope and believe that they will take an open approach, as they recently did with the fingerprint API, which they have opened for third-party developers.
Okay, thank you very much, Victor. I think this is the end of our session today. If you have asked a question that we have not been able to answer during the session, we will make our best to answer in the coming 48 hours. So thank you for joining the OSPT Alliance webinar. We look forward to receiving any feedback that you may have. And of course, we expect to get your support during our next sessions. Please don't forget to fulfill the survey, which will appear on your screen whenever you leave the session, and provide your feedback about this webinar. Thank you for now, and goodbye.
Bye-bye.